Hello and welcome to Haute Engineered. Lightning strikes are one of nature's most fascinating and destructive phenomena. But did you know that scientists can recreate them in a laboratory? Today, we'll show you how it's done. In this video, we'll explore why scientists recreate lightning, the equipment used, and the incredible science behind it. Understanding lightning is crucial for improving the safety of electrical systems, creating better insulation materials, and studying the effects of high-voltage surges on various materials. In high-voltage laboratories, researchers recreate lightning to test the insulating materials used in high-voltage systems. For instance, mineral oil, which is commonly used as an insulator in high-voltage transformers, is subjected to lightning-like discharges to evaluate its performance under extreme conditions. Additionally, these experiments are essential for testing the effectiveness of protective devices such as lightning rods and surge arresters. These devices play a critical role in safeguarding electrical infrastructure from direct lightning strikes and the resulting overvoltages. Scientists study the electrical and acoustic characteristics of lightning, such as the voltage, current, and the shockwave it creates. This information is crucial for developing technologies that can detect and locate lightning strikes more accurately. To recreate lightning strike in a laboratory, scientists use specialized equipment. The first equipment is what we call a Marx generator. A Marx generator is a high-voltage device designed to simulate lightning strikes and other electrical discharges. It works by charging a series of capacitors in parallel and then discharging them in series, creating a sudden and powerful voltage surge. The rest of the equipment used in this setup includes several key components. First, we have the Marx generator, which generates an impulse high voltage that can reach millions of volts. This is connected to a voltage divider, which scales down the output voltage to a measurable level for the oscilloscope. The high voltage output is then connected to an electrode positioned at a fixed distance, typically 1 meter, from a grounded rod, with air serving as the dielectric medium. When the voltage exceeds the breakdown strength of the air for the given distance, the air becomes conductive, resulting in a powerful electrical discharge. This creates a massive arc between the high voltage electrode and the grounded rod, simulating a lightning strike. Now that we've recreated lightning in the laboratory, let's explore the fascinating physics behind how it happens in nature. Lightning is a massive discharge of electricity caused by the buildup of opposite charges between a storm cloud and the Earth. The charged region in a cloud is typically 5 to 15 kilometers above the ground. As a storm cloud gathers more charges, the potential difference between the cloud and the Earth increases dramatically. This happens because the cloud's bottom layer accumulates negative charges, while the ground below becomes positively charged due to induction. The electric field between the cloud and the Earth grows stronger until it reaches a critical point. At this moment, the insulating air can no longer hold back the massive electric force, and a sudden discharge occurs. This is the lightning strike. To give you an idea of the immense power of a lightning strike, distance between the Earth and the cloud can range from 5 to 15 kilometers. The voltage can exceed 100 million volts. The lightning channel can reach temperatures of 30,000 Kelvin. That's about 5 times hotter than the surface of the sun. The current can range from 30,000 to 100,000 amps, all occurring within just a few microseconds. Well, that's it for our video today about lightning strike. Thank you for watching.